Hello, Algebra 2 students, and welcome back to, or I shouldn't say welcome back, I should say congratulations on finishing Chapter 8. Now we're on to Chapter 9, which deals with rational functions. Okay, so here we're going to start dealing with rational functions. Well, we should probably figure out what a rational function is. Now would be a great time. Pause the video, get everything written down on the screen. All right, so here we have, now that you've had a chance to write all this down, rational expression is something written as a ratio, okay? Two polynomials written as a ratio. Such as here I have a linear binomial that's getting divided by a quadratic trinomial, okay? And these type of things happen quite a bit, okay? This is used to predict, stock market. This is used to find the sides of a box. Okay, we got all sorts of stuff going on here. All right, so we need this in real world applications. Now, of course, usually what we do in maths, we get stuff into simplified form. All right, as I'm working through this video, you need to be pausing the video and writing down the notes. Okay, it's not good enough just to listen to me, but I'm not going to build in a pause every single time you should write down your notes. Okay, so it's simplified when you don't have any common factors left. Okay, other than one, like we don't really think of that. Okay, now it says you do not reduce terms, you reduce factors. I've talked about this idea of factors. Okay, that means you can't cancel things, okay, that are tied to addition and subtraction. Don't cancel across addition or subtractions. Okay, in other words, don't do this here. I've shown this before many times in every class. You cannot simply get rid of this and get rid of that. It does not work that way. Okay, it does not work that way. You cannot simply just get rid of those. Okay, the easiest way to show that, okay, would just be numbers, right? If I put numbers there, that wouldn't work either. It still doesn't work here. We cannot do that. Okay, you can't just cancel those out. So, like, how would I do it? If I can't just cancel those out, Mr. Khan, then how do I go about this problem? Well, we've seen this stuff. Up here we got a quadratic trinomial. Well, can I make that into two binomials? Do I know factors of x? Oh, well, I have x squared, that's x and x. Do I know factors of 15 that subtract to give me 2? Well, yeah, that's 5 and that's a 3. Right? 5 and a 3. Okay, well, which one's got to be negative? Well, the 5's got to be negative, 3's got to be positive. Okay. Now, basically what I've just done is this is the new top. Well, can I do anything to the bottom then? Well, again, this is a special type of factoring. X's, factors of 9. Okay, 3 and 3 that subtract to give me nothing. Oh, so one's positive, one's negative. So I'd have x plus 3 here, then an x minus 3. These are the same thing that I just wrote. Okay, exact same thing. Now here, okay, before I just threw a big fit, said you can't just cancel out this x squared like that because it's tied to this subtraction and this one's tied to this subtraction. But here, can I cancel out this x plus 3 and this one? This is fundamentally different because this entire thing right here is not tied over here to this x minus 5 through addition or subtraction. It is a multiplication sign. Same with this one down here. So I can cancel those. Oh, so the new one would be x minus 5 over x minus 3. And then this is simplified form. And this is what we're really hitting on today. Okay, that's simplified form. Well, here's another one. Again, now's a good time to pause the video. Here's another one. Well, can I do anything here with the top? Well, when I look at it, I think that a 2 goes into both 4 and 6, and they both have x squareds. So that would be a 2, x to the third left, minus 3. Okay, well, that's not too bad. And I work on the bottom, right? Oh, the bottom here. What? Oh, those share an x times 2 2x plus 3. Okay. Oh, well, now when I'm looking at it, these are different, right? This right here, this binomial and this binomial, they're different. I can't do anything with them, okay. But I do see that this x is to the first. It will cancel out with one of those, makes it a 1. That's gone. Well, what do I have left? That's 2 times 2x to the third minus 3 divided by 2x plus 3. Okay. Now, before you think that you can get away with canceling this 2 and this 2, remember that this 2x is bound to this 3 through addition, so I can't touch it. I am done. This is it. This is simplified form. Okay. Huge premise of the lesson. Great time to go back, rewatch that section of the video. Okay, what did I just get done doing? Well, I just got done simplifying a rational expression. Well, how did I do that? Well, I factored the numerator and the denominator. I reduced any common factors, okay? Anything that I saw that was multiplying out. Now, this last part I didn't do. I didn't do this last part, okay? It says state the excluded values. Values that would make the denominator 0 at any point in the problem. I mean, this is bolded here. I mean, I'll box it here. I think I'll like asterisk it, right? I mean, this is just huge. This is just huge. This is so hard for some students to grasp. This is what I said was coming, okay? Why we get rid of some values. If I go back, I'm going to go back to the other ones, okay? Here, I stated this problem here, okay? Got simplified down to this form. There's one other thing I need to do, and I need to state my excluded values, EVs. Okay, when did the denominator ever become 0? Here, when I look at x minus 3, that's in the denominator. What value could I plug in for x that would make this whole thing 0? Oh, well, that would be 3. Well, if I get 0 on the bottom, that's bad, so I can't be 3. Well, what else can I not be? Remember, this is at the very end of the problem. Oh, up here, I have x plus 3 in the bottom. Well, that would be a negative 3 would make that bad. Because if I plugged in a negative 3 here, that means 0 times negative 6. On the top, I would have 0 times negative 8. Well, again, this is going to be 0 over 0. Is that a problem? Yes. Big no-no. This is bad. Okay, which is why we state the excluded values down here. Okay, well, let's try this other one. Here, what would be my excluded values? This one might not be so simple. This is the bottom, right? It's not supposed to be able to be 0. We'll solve that. Let's solve that. So I'd take it out. That's 2x plus 3 can't equal 0. Oh, well, then 2x can't equal negative 3, subtracting it. X can't equal negative 3 over 2. Okay. Well, are there any other points that I have to worry about? Well, here, down here, right, we just did this one. Let me give me a different color here. But I didn't tackle this x. Oh, well, what will make that 0? 0. And these are the excluded values. Okay. That's a quick snippet over that, all right? Let's keep going in the notes. We'll see what we can get through here. So an excluded value is a number that makes a rational expression undefined. Well, why does it undefined? Well, that's because the denominator can't be 0. Denominator can't be 0, which is what we were just covering. These are the notes. You need to pause the video if you need them. So finding excluded values. To find the excluded values, set the denominator equal to 0, and then solve the equation. Exactly what we did, okay? Here, I think what I'll tell you, okay, is have it in factored form. Okay, not simplified form, factored form. And then we got some examples. This is a great time to pause the video, get these two written down and try them. Okay, now that you've had a chance to try those. Okay, I think I'll do them. Down here, this, I should factor it. Okay, it's 2 times x plus 4. Okay, that's the new bottom. Well, when does the bottom equal 0, right? This is a problem. So well, I don't have to worry about that 2 at all. So I just think I have x equals -4 is the excluded value. Well, we put can't be that. That's why we're saying exclude them. Can't be. Okay, well, down here, I have 5x. Oh, 5x equals 0. Oh, x equals 0. Oh, well, I can't have x equal to 0 then. Notice, I am not touching anything up here. Don't care. Top can be whatever. Okay, top can be anything it wants. All right, a couple more. Now would be a great time. Pause the video, try it out on your own. Okay, now that you've had a chance, I only care about the bottoms. When does 6 equal 0? Never. Oh, no. And that is absolutely terrible handwriting. Let's see if I can make that a little bit better. No excluded values. There aren't any here. Plug in whatever I want. I'm good to go. That's nice. Okay, well, this other one, 3x minus 2 equals 0. Well, that's 3x equals 2. That's x equals 2/3. Oh, x can't be 2/3. It's as simple as that. Okay, great time to go back. Really make sure you're getting these excluded values because we're going to be using them. Now I just want to simplify some rational expressions and state the excluded values, though. That's a key. So I got 1, 2, 3 problems there, and then that's it. That's all I want to do. Okay. So here's a nice time to pause the video, okay, and try this sucker out. All right, now that you've had a chance to try it, I'm going to factor the top. These are perfect cube, trinomial, or perfect cube, difference of perfect cube. We've done this. This is where we do, oh, the cube root of x cubed is x. The cube root of 27 is 3. It's this thing, right? Oh, and then I use this binomial to do the rest. So it's x, that thing squared. Then it's a times b, so that's x times 3, that's 3x. And then the last thing squared, which would be 9. And then I use SOAP. So according to my sign here, it's the same, opposite, always positive. All right, well, I got that thing factored. Then I go after the bottom here. Right, I'm going after this bottom, and I'm wondering if anything comes out. Well, I think a 3 comes out of these, so I'll take that out. So then I would have x squared minus 9, right? Now, this 3 came out. Does this factor more? Well, of course it does. We just did that one earlier. It's x, x, I have a 3, a 3. This is a plus and then a minus. We've done this factory before. You're not allowed to forget those. This thing here that I just did, right? This is factored form. Very useful, okay? Now that I have it in factored form, it is super helpful if I just take the time to do the excluded values now. Okay? So x cannot be. What makes the bottom 0? Well, here I'd have to try to tackle this very first one, right? I'm looking at just, let's see here, just this right here. Okay, what can x not be? Well, that would be a -3 would make that bad. Or, well, then if I look at this other one, right? What makes that 0? 3. Great. I don't have to worry at all about this other little 3 sitting out here. No biggie. Okay. Now after I look at it, hopefully you're seeing, oh, this is a x plus minus 3 there, x minus 3. So I've stated my excluded values. Well, what's the leftover? X squared plus 3x plus 9 divided by 3 times x plus 3. And this is the answer. Right there, done. Of course, some of you are freaking out like, hey, why didn't he try to factor the trinomial? Remember that we did that with SOAP before. That will never factor. All right, we're on to our next example here. Again, you should try this out on your own. You really should. Now that you've had a chance, I think I'll go through this here. I am trying to factor this out. I'm thinking of factors of 16 that add to 8. Do I know any of those factors of 16 that would add to 8? Well, I think 4 and 4 do. This is a plus, so I know the signs are the same. This tells me what kind, so they're both negative. Draw my line. Now I try to conquer the other one. Again, factoring it out. Do I know factors of 24 that subtract to give me 2? I think that's 6 and a 4. I would need a, what, positive 6, negative 4. This is factored form. So if it's factored form, I should take the time right now to find the excluded values. What can x not be? Well, negative 6 would make that a problem in the bottom. Or 4 would make it a problem. Okay, well, now moving on. I'm looking at it. These go away. I got x minus 4 over x plus 6. This is my final answer, and these are my excluded values. Okay, let's keep working our way through. We got one more problem to get through. Coming up on a 20-minute video here. Well, let's factor this thing out. What goes into those? I think 9x squared comes out. So that would be x minus, what, 2. And on the bottom here, what, this thing here, well, let's try it. I see that they share, what, a 3x? Take that out first. That would be 3x squared minus 2x minus 8. Okay, now this is a little tricky one maybe here. I think this factors again. Okay, I think this factors again. The easiest way to tell is if you take this 3 times this 8, that would be 24. Do you know factors of 24 that subtract to give you 2? Well, yeah, we do. Once we say yes, that means it'll factor. Okay, how do I want to break the 8 down? Well, factors of 8 are 1 and 8, 2 and 4. What do I want to place here at the end and here to get the 2 there? Well, if I put the 2 over here, this one here, then that'll give me 6. Oh, and then if I put the 4 here, that'll give me 6 minus 4. Great, I need this 6 to be negative, the 4 to be positive. Now this factors here, I'll put it on the bottom. The whole bottom now is this big long thing. Okay, that big long thing there. This again, factored form. So I should take the time right now, do the excluded values. X cannot be, oh well, what would make this part 0? 0. What would make this part 0? Well, that, I think after you do your little math there, that's negative 4/3. And then 2. So I have 3 excluded values. No biggie, okay? That is no big deal. We can have that many. Then this x minus 2, I wanted that to be black, cancels with this x minus 2. I have this 3 goes with this 9, makes it a 3. This x goes with this 1, makes it a 1. It's kind of sloppy, but I think I can see it. It's 3x. Oh, there is nothing left up there. I canceled out that x minus 2. Divided by, oh, what's on the bottom? 3x plus 4. This is my answer, pieced with my excluded values. Last thing. Okay, last thing, and then I'm going to stop on 9.1 video. No, you cannot cancel this 3x and this 3x, because this 3x down here is tied to the 4 through addition. Okay. Thank you. The 9.2 video is coming up next.